Let's now go through our workbook exercise 3C question 4, which was our homework question. So we have a fraction divided by a fraction. We said that we should keep, change, and flip. So we have 3r squared over 4 change and flip 10 over 9r. And then we taught you to put all the numbers together first. Divided by 4 times 9 times r. Okay, so put the numbers into our calculator. You end up with 30 divided by 36. So your calculator will say 5 over 6. And now you need to decide what is going to happen to the letters. So if you've got r squared divided by r, if you do your cancelling or you do a division, numerator and denominator both divided by r, you'll be left with just r in the numerator. So if you want to cancel, make sure you use your pencil and you cancel this way. So our answer is simply 5r over 6. Next question, similar concept, keep, change, and flip. So we end up with 2x y squared over 9x, change and flip 6x, 4. Put the numbers together, 2, 6. So now we have x squared, y squared. 9 times 4 with x. Okay, put the numbers in our calculator. You have 12 divided by 36, which your calculator will say 1 over 3. So if you want to do the cancellation for the letters, you've got only one x that is common. So now we're going to end up with xy squared. So 1xy squared over 3, we want to write it as xy squared over 3. There's no need to write the number 1. Here's your last homework question. So 7p over 4m squared change, but this time your fraction has a negative sign. So we said that the negative, whether it belongs to the numerator or denominator, does not matter. So now we're going to flip it. We're going to give it to the 2m divided by 14pm. So put the numbers together, 7 times negative 2 pm, 4 times of 14, pm to the power of 3. Okay, so calculator, put in the negative 2 times 7, so we end up with negative 14, and we're going to divide by 4 times 14. So your calculator will tell you that, okay, the answer is negative 1 over 4. So you have to decide for the letters. Okay, so there's a common p. There's one m that is common. So instead of 3 at the denominator, we only have 2 left. So in our fraction, we have negative 1 over 4 m squared. That's the answer. Now let's go on to our textbook. Okay, so chapter 3. The next part is on number patterns. So go all the way to past the division. Okay, here. Finding the nth term of a simple number sequence. So in primary school, or we have seen number patterns, for example, 2, 5, 8, 11. You know that we will need to add 3 to get to the next term. So we need to know some of the names also. For example, this over here, we call it the first term. Okay, over here, first term. The first term has a value of 2. The second term has a value of 5, and so on and so forth. So it is very easy for us to find the next term and the next term because we just keep adding 3 only. So assuming the pattern continues, how do we find the 5th, 6th, and 7th? So to find the 5th term, right, they gave us until the 4th term, right, which is 11. So you just need to add 3 to get 14, add 3 to 17, add 3 to get 20, and so on. But what happens if we want to find the 50th term? There are a lot of missing numbers over here. So if you have to keep adding, it takes a very long time. So we want to find a fast way to do it. Okay, so let us come up with a formula. Suppose we know that for the nth term, so nth refers to the number. For example, first term, second term, third term, we do not know exactly which term they want, so we call it the nth term. It has this such formula. Okay, so the nth term is equal to 3n minus 1. With this formula, we can find any term. For example, let's look at the first term. The first term, all you need to do is to replace the letter n with 1. This was the formula given, 3n minus 1. They gave us this formula. So change the n to become 1, and we get 2. For the second term, just change the n value to become 2. Put it in your calculator, you get 5, and so on and so forth. So this works for all the terms that we found out, that we saw in the pattern earlier on. So with this, to find the 50th term, all we need to do is, when n is equal to 50, 3n, change the n value to become 50. 3n minus 1, we get 149. So in this way, we do not need to keep adding to find the 50th term, and it becomes very powerful. Okay, so that's what this over here is describing to us. So let us look at work example number 10. Now they tell us that, hey, there's a formula, the nth term. The formula is 4n minus 2. So find the first 4 terms, meaning they want you to find the first term, second term, third term, fourth term, and then find the 50th term. So let's look at the working. Let's start with the first term. Given this formula, 4n minus 2. When n is equal to 1, substitute 1. You get 4 minus 2, which is 2. For the second term, just change the n value to 2. Third term, change to 3. Fourth term, change to 4. So we have now found the first 4 terms. So term number 1 is 2, term number 2 is 6, then 10, and then 14. Finally, they wanted us to find the 50th term. Very simple. Same formula, change the n to 50. Press calculator, get your answer. And here's our answer. So in your presentation, you just write first 4 terms are 2, 6, 10, 14. 50th term is 198. So let us look at try it 10. Again, find the first 4 terms of the sequence. This time, this is our formula. Okay, so you can draw that nice table. Just follow over here. Nth term, first, second, third, fourth. So this is the nth, first, second, third, and fourth. The nth term, they told us it is 5n plus 3. In our first term, it will be 5 times 1 plus 3. Second term, 5 times 2 plus 3. Third term, 5 times 3 plus 3. 5 times 4 plus 3. So take our calculator, find all these values. 5 plus 3, 8. 10 plus 3, 13. 15 plus 3, 18. 20 plus 3, 23. I've got the first 4 term. And then they want us to find the 50th term. So 50th term will be 5 times 50 plus 3. We get 253. So first 4 terms are 8, 13, 18, 23. Notice that we are just adding 5. And then the 50th term is 253. Okay, so try this. Now the next question is, hey, what if they don't give us the formula? Are we able to create the formula ourselves? So for example, if they tell us that, hey, the sequence are 2, 5, 8, 11. Find the formula for this. Well, how are you going to do that? So it's not difficult. Because the first thing you'll notice is, hey, we're just going to be adding 3 all the time. Plus 3, plus 3. Definitely has something to do with the plus 3. Okay, so whatever you see over here, in this case plus 3, I want you to write plus positive 3 plus is positive, so plus 3 is the same as positive 3, but you multiply it by n. So if our sequence is a case of plus 2, plus 2, plus 2, I want you to write 2n. If the sequence is minus 5, minus 5, minus 5, and so on, I want you to write minus 5n. Okay, so in this example again, we've got a 3n. The next step is for us to compare with each term. This is the original pattern given in the question, 2, 5, 8, 11 over here. And then when you created your 3n, you're going to get 3 times 1 is 3, 3 times 2 is 6. Basically, your 3 times table, 3, 6, 9, 12. Now that we have our 2 rows, okay, so this was our original. This is our 3 times table. You just need to compare the difference between your 3 times table and the original. So to go back to the original, you notice that, hey, 12 minus 1 gives me 11. 9 minus 1 gives me 8. 6 minus 1 gives me 5. 3 minus 1 gives me 2. Oh, now you realize that to get back the original, you just need to take your 3 times table minus 1. So here was your 3 times table, and then you minus 1. Done. This is now the formula. Okay, we're going to try an example. So here we have a worked example number 11. Find the nth term of the number sequence 3, 8, 13, 18. So we know that, hey, over here we just plus 5. Plus 5, plus 5. So very quickly write down 5n. This is definitely part of your formula. Okay, so this is 2 rows, your original. And then this is your 5 times table. 5, 10, 15, 20. Just compare them. From 20 to 18, I had to minus 2. Here, minus 2, minus 2, minus 2. So you just take your 5n. Earlier on you found it, right? Just put a minus 2. Done. This is our formula. So they wanted the 50th term. Just substitute when n equals to 50. This n is 50. So 250 minus 2 is 248. As straightforward as that. So try 11. Okay, you can pause the video here. Try. We're going to plus 4, plus 4, plus 4. Definitely, I have got a 4n somewhere. Now I'm going to line up my 4 times table with your 5, 9, 13, 17. So 4, 8, 12, 16, right? And so on. So how do I go back to my original? Okay, over here, your 4, 8, 12, 16 is the same as your 4 times table. I want 5, 9, 13, 17. I do not want 4, 8, 12, 16. So what I notice is that, hey, to go back to the original, I had to plus 1, right? It is just a plus 1 all the time. So just include a plus 1. This is now my formula. In order to find the 100th term, 100 term is 4 times 100 plus 1, we get 401. Rather than you trying to add plus 4 so many times to find the 100th term, we've got our formula here. Okay, so I wanted you to complete exercise 3D for your holiday homework. So pause the video here, stop the video here, give it a try, and then we look at the solutions. Right, so nth term is 7n minus 3. Find the first 4 term and then the 50th term. So nth term, 7n minus 3. First, second, third, and fourth. And then our 50th term. First, second, third, fourth, 50th. So the formula is the same. 7 times 1 minus 3. 7 times 2 minus 3. 7 times 3 minus 3. 7 times 4 minus 3. 7 times 50 minus 3. So take our calculator, work them out. This will give us 4. This will be 14 minus 3 is 11. So you notice that we're just adding 7. So 18, next one plus 7, we get 25. Next, 7 times 50 is 350. Then minus 3, you get 347. So first, 4 terms. 4, 11, 18, 25. 50th term, 347. Okay, so I told you we didn't need to do question 2. We also do not need to do question 3. And now question 4. So here is where we have to find the formula. It's not given to us, we need to find out ourselves. So same method, our step 1, we need to look at the pattern. Oh, okay, we're going to plus 8. Plus 8, plus 8. So definitely in our formula there is a 8n. Okay, so next, we want to write down our 8 times table. 8, 16, 24, 32, so on and so forth. We compare our 8 times table with the original. How to go back to the original? We need to minus 7. Double check. Yeah, you're subtracting 7, minus 7, minus 7. So just put a minus 7 here. And now this is our formula. In order to find the 20th term, this is our nth term, nth term. So the 20th term will be equal to 8 times 20 minus 7. So 160 minus 7 gives us 153. So same thing here. We are going to add 10. So definitely we have a 10n. So you write down 10 times table, 10, 20, 30, and 40. How do we go back to the original? You need to minus 8. All of them minus 8. So our formula is 10n minus 8. They wanted the 20th term. So 20th term, 10 times 20, then minus 8. 200 minus 8. We get 192. Next, part C. Notice that we are adding 4. So our nth term will have a 4n. Put on a 4 times table. 4, 8, 12, 16. To go back here, you need to plus 7. Okay, all of them plus 7. So just put plus 7. They wanted the 20th term. So change your n to become 20. So 80 plus 7 is 87. Now we have a question that's not so straightforward, but they explain what's happening. So don't be afraid of this kind of problem sums. You've got wooden blocks that are arranged one on top of the other in a design. The number of blocks for each row will follow a sequence. So the first row we've got 3, then 5, then 7. Let's count. This is my first row. 1, 2, 3. Okay, so that's the 3. My second row. 1, 2, 3, 4, and 5. That's the 5. And then the third row. Third row we have 1, 2, 3, 4, 5, 6, and 7. Okay, and so on. So find the nth term. Notice that we just need to plus 2. So the nth term definitely will have a 2n. So put on a 2 times table. 2, 4, 6. So to get back to the original, you just need to plus 1. So 4 plus 1 is 5, 2 plus 1 is 3, plus 1. Okay, so we have done part A. Part B says, using the nth term, find the number of blocks in the 25th row. So you don't have to draw the whole design out. You just need to write down 25th term. Using the formula here, n term 2n plus 1. 25th term, 2 times 25 plus 1. So we get 51. Okay. So that's all that I needed you to do. Review exercise 3. Please complete this before the